Hello, this section is about 1-4 in your college algebra book. This is solving quadratic equations. So the first thing that we need to talk about is what is a quadratic equation. A quadratic equation looks like this, where it's got ax squared plus bx plus c. That's what a quadratic equation is by definition. And where a, b, and c are going to be numbers for us. The main thing, the reason why it makes it a quadratic is the fact that our x squared right there is, or our highest exponent, our degree of it, is going to be squared. Okay. Now I'm going to walk you through 3 different methods of solving these today, and basically it's up to you to decide whichever way you would like to do it best. However, I'm going to show you all 3, and then from there you get to make the choice. So, first things first, the first one I'm going to show you is the factoring method. Okay, so if you've got a question like x squared plus 5x equals 24, the first step that you need to do is set the equation equal to 0. Right now it is not. So what you need to do is you need to make sure that everything is on one side versus the other. Which side you move it to, it is totally up to you. I'm going to move everything to the left, and the reason why I like to move it over that way was only because the x squared is going to stay positive then. Okay? So that is the first thing that I'm going to do. Second thing that I'm going to do is I'm now going to factor. Okay, and when I factor, I do a couple things. First thing I'm going to do is I'm going to look to see if there's anything I can take out of all 3 terms, which there is not. If, for instance, they were all divisible by 2, I could take a 2 out, or a 3, or whatever like that. But since they're not, I'm going to leave it alone that way. Second thing is, because it is a quadratic, I'm going to set up a set of 2 sets of parentheses. Now when I set up 2 sets of parentheses like that, I'm going to ask you some questions from it. First question I'm going to ask you is, what times what gives me x squared? X and x are the 2 things that multiply together to give you x squared. Second question I'm going to ask is, what times what gives me negative 24? So over here on the side, I'm going to put 1 and 24, 2 and 12, 3 and 8, 4 and 6. Now, because this is a negative right here, that means I know that one of them has to be negative and one of them has to be positive in order to do that. They need to work together with the front in order to make the middle work. Okay, and what I mean by that is, somehow, some way, I'm going to have to use these 2 plus the x's and x's, or these 2 or these 2 or these 2, to make a 5 in the middle. But the only way that I can do that, I think, is if I go plus 8 and a minus 3. Now it has to be a plus 8 and a minus 3, because when I refoil it, this would give me 8x, that would give me negative 3x, and when I add that together, that gives me 5. So, just so that you are aware of it, that it does make a difference what sign is on which one, and that it makes the original problem. If it does not make the original problem, it's not right. Now, once you get it into this stage, once it's factored, what you're going to do is you're going to set each group, or each set of parentheses, equal to 0. And what that's called is called the zero product property. What you're trying to do is you're trying to find whatever x is going to equal to. So I'm going to add 3 to both sides. That gives me x equals 3. And I'm going to subtract 8 to both sides, and that gives me x equals negative 8. Now, if you want to check these, you're more than welcome to check them. All you have to do then is put those numbers back in and see if they actually equal 24. So if I went 3 squared plus 5 times 3, does that equal 24? I'm putting it back into the original equation, and I'd do the same thing for the negative 8. So that is factoring. Now factoring works well if you're a really good factorer. If you've had a lot of practice at factoring, it could be very quick and very easy. However, not all of them are going to factor, so factoring kind of gets put off to the side just because of the fact that sometimes it takes a little bit of time, plus the fact that not every single one of them is going to be able to factor. All right, so but that is the factoring method. Second one that we're going to show you is I'm going to show you the completing the square method. Now this one, from my experience with this one, most people do not like this method. Realistically, I think it's a little bit. It's one of those things where it takes a little bit more time than others. Me personally, I don't particularly use this one for when I'm solving quadratics. I use a different method, but it is one that works, and it does work especially really nicely for writing circles in the standard form of a circle, or writing parabolas in the standard form of a parabola. So just so that you are aware of it, it has other uses just besides solving this. So first one I'm going to give you, it says x squared minus 8x plus 13. Now the first thing that needs to happen is the number that's in the a position needs to equal 1. If it's not, you need to make it. Okay, so for this particular one, I'm looking at right here. It is a 1. If there's not a number listed, it's understood to be 1, so therefore we're good and set up. If it wasn't a 1, I would divide every piece by that number. Now that could lead us to having fractions, and usually that's not a very good outcome for most people, but it is something that we could do. Second thing that you're going to want to do is move c to the other side. Okay, and what c is, again, is c is the one that does not have a letter attached to it. So I'm going to take and I'm going to subtract 13 to the other side. Now, one of the things that I hope you notice is I left a spot open for where the 13 was. Okay, that's an important part, is I'm gonna fill that with something that's going to allow me to factor easier. The third step is where this gets its name from, and that is b divided by 2 squared. So what I do is I take whatever is in the b position, which in this case it's negative 8. I divide it by 2 first, and then I square it. So what I end up having to do is I have to do this to both sides. Okay, so that needs to be added into both sides. So I'll put that in a different color here. So I'm going to put plus 16 here and plus 16 there. The reason why you do it onto both sides like that is if you do something to one side, you're unbalancing the equation when we want to keep the equation balanced itself. So if you do something to one side, you need to do it to the other. That's why it's an equation, because of the equal sign. The fourth thing that you're going to do is you're going to factor the x side. Now I say that because it doesn't matter what side you move your x's to, but you're going to factor the x side and add the other side. And all I mean by add is just combine like terms. So for this particular one, you'd have x minus 4 times x minus 4. And again, there's where my factoring stuff comes into play. Same kind of rules. What times what gives me 16, but adds up to be negative 8x. Okay, equals 3. Now, one thing I want you to notice is that this number right here is a negative 4, and both of these are also negative 4. That's not a coincidence. That's supposed to happen. When you have the same group twice like that, you can rewrite it as squared rather than individual pieces, and it'll make it easier for you if you do. Then the fifth step that you have to do is you have to square root both sides. Okay? So I'm going to square root both sides of the equation. When I square root something squared, I just get the inside material. And on the right hand side, it's plus or minus the square root of 3. Now if the square root of 3 broke down evenly, like if it was square root of 16 or square root of 121 or something like that, you'd have plus or minus whatever that number happens to be. The reason why it's plus or minus is because when you're squaring it, if you square a negative, you get the positive, and you also, if you square a positive, you get that positive. So it is important that you have plus or minus there. Then the sixth thing that you have to do is solve for x. So I'm going to add 4 to both sides. Now, one thing that I want to make sure that you are aware of, unless the directions say, round to the nearest hundredth or whatever it is, you go ahead and leave your answer just like that. 4 plus or minus root 3. Because the square root of 3 is an irrational number. That's a number that goes on forever without ever stopping, without ever repeating. If you wanted to actually write that number out, you would be writing that for the rest of your life. And trust me, I know you want to have a life, so therefore you're going to leave that answer alone. Okay, so that's completing the square. I'm going to do one more with you and walk you through it just so that way you can see it again. But and I'll give you one that does not have a is 1. That's 12x plus 6 equals 0. Okay, again, going through the steps. The first step was, is a 1? If not, make it. So since it's not, I'm going to divide every piece by 3. Now, this particular problem, it worked out nicely where when I divided it by 3, every single one of them came out to be whole numbers. Most of the time, it's not that easy. A lot of times it does not come out perfectly like that. So therefore, we're going to have to do a lot of other little things. Then from here, I'm going to move the constant to the other side. So I got x squared minus 4x equals negative 2. And then I'm going to take the b, negative 4, divided by 2, and square it to both sides. That ends up being negative 2 squared or 4. So I'm going to add 4. Now it's on to factoring. Instead of writing it down as two separate groups, I'm going to write it as one group but with a squared up there. Now again, this number here and this number there are the same thing every time, which makes it a lot easier when you're dealing with fractions. Now, you square root both sides. When you square root a square, you just get the inside material, plus or minus, and then the square root of 2. Square root of 2 does not break down, so we're going to leave it as the square root of 2. We're going to add 2 to both sides. And when you have a number that does not have a square root and a number that does, you just simply put it as 2 plus or minus root 2. Okay? And that's my answer. So again, that was completing the square. I usually use that more for writing out parabolas or writing out equations of circles so that I can find the center and the radius or the vertex. I usually don't use it to solve quadratics, however we can. So that's completing the square. The last method of solving this stuff is using what we call the quadratic formula. Now, this one, I've noticed over the years that this is the method that most people prefer, the quadratic formula. They'd much rather write it as this and then simplify it from here. Me personally, unless I can factor it fairly quickly, I also do this one too. It's just so much faster, so much more efficient, plus the fact that if it has a number in front of or in the A position that's not a 1, I don't have to worry about dividing it and then worry about having fractions until the very end. So the main thing with this that has to happen is that it needs to have everything to one side versus the other. Okay, so you need to have your A, your B, and your C all in one side, rather than opposite sides or whatever like that. So a problem like that, if I have 3x squared minus 5x minus 1 equals 0. So first of all, everything is on one side. Oops. Everything to one side, which it is. If it wasn't, I would move it over by adding or subtracting. Second thing they're going to do is put numbers into their spots and simplify. So minus, and then in the B position right here is a negative 5. Plus or minus the square root. Negative 5 is still the B, minus 4 times the A position, which is the 3, times the C position, which is negative 1. All over 2 times A. Now, a couple of years ago, I had a student teacher that actually referred to this as the plug and chug method because of the fact that they were just plugging in numbers and chugging through the problem. As soon as you do this, the order of operations take over. Okay, so the order of operations, we're going to do a couple things. First of all, two minuses there make it a positive 5. Then we're going to square this thing in here. Negative 5 squared is 25. Don't rely on your calculator too much for this unless you put it in parentheses. Negative 5 squared is really negative 5 times negative 5, which is positive 25. If you put it in like this in your calculator, it's going to tell you negative 25 because that's telling you the opposite of 5 squared. So be very careful. A lot of people screw that up because they would just type in the calculator and they put that number in there when that number is actually wrong for our problem. So be very careful. Then the last one too, this whole grouping here, that's one big multiplication problem where you're taking negative 4 times 3 times negative 1. Two negatives will make it a positive. Now, will it always be a positive? No. But in this particular problem, it is. Okay? You need to be very careful and be mindful of your signs. Go slow. Make sure you take your time and get your signs right. Because if one sign's wrong, you could be wrong. Then on the bottom, 2 times 3 is 6. 25 plus 12 is 37. And now from here, if I can, I'm going to try to break down the square root of 37, but this 37 itself is a prime number, so therefore that is the final answer. If you were in a high school setting, 5, 6 plus or minus the square root of 37 over 6 would probably be the way that you're going to write that because of standardized tests like the ACT or SAT. So those are kind of set and designed for that. And what happened was that I just put the 6 underneath each of the pieces. Then if I could reduce the fraction after that, I would do that. But I don't have to in this particular context. But that is my quadratic formula, or is that's how I found that answer. Do one more with you. 4x squared plus 12x plus 9 equals 0. Okay, again, first thing I'm going to do, make sure it's equal to 0, which it is. Now I'm going to put my numbers into my spots. So minus the b, which is 12, plus or minus the square root of 12 squared, minus 4 times the a, which is 4, times the c, which is 9, all over 2 times a. A negative with a positive on the outside makes it negative. And then 12 squared is 144. And then negative 4 times 9 is also negative 144. Now the reason why it was negative in that case is because I only have one negative there. And on the bottom, 2 times 4 is 8. Inside the square root, I end up getting negative 144, or 144 minus 144, which is 0. And the square root of 0 is 0. So I end up with negative 12 plus or minus 0 over 8. Now a lot of times when they do work out like that, some people like to just leave it like that, which you always, if this is a number right here that does not have a square root anymore, you should get two different answers. So for in this case, I'm going to do negative 12 plus 0, which is still negative 12, over 8, which reduces down to negative 4/3. And then it would also be negative 12 minus 0, which is again still negative 12 over 8, which is also still negative 4/3. So that is my final answer. It would have been the same group twice. Had I found, oh, not negative 4/3, what am I thinking? That was not negative 4/3. I can't reduce this morning. Negative 3/2. Sorry, I reduced that wrong. Okay, and that's something that if you would have factored it, you would have got the same group twice, and saw that it would have been the same thing. So that's the quadratic formula. Next in this section, it talks about the word discriminant. And what the discriminant is it's a formula that will tell us and allow us to determine what kind of solutions we're going to have. Now, if that b squared minus 4ac looks familiar, it should. We just talked about it with the quadratic formula. It's the number inside the house. So if you do b squared minus 4ac, and you have a number greater than 0, which is a positive, then you should have two real solutions. So this is what the discriminant will tell us, is it will tell us how many and what type of solutions we're going to get. If our b squared minus 4ac was equal to 0, which on that last one it was, we'd have one real solution. And like that last one, we only had the one answer, we had negative 3 over 2. Then if my b squared minus 4ac was less than 0, which means it's a negative number, I have 0 real solutions. I cannot square root a negative number and be real. It's just not possible. So on this particular section, we are just getting real solutions. We are not getting imaginary solutions yet. That will come in another section. But for this particular one, we'll only have the reals. So a problem like this, it's going to look very similar to all the other ones where it's going to have the numbers or the quadratic formula or equation set up, and it's going to say use the discriminant to determine the number of real solutions of the equation. Do not solve the equation. So for this, I'm going to go ahead and put it into my formula. So b is going into b, minus 4 times the a times the c, and now I simplify. Negative 6 squared is 36. Negative 4 times 1 is negative 4. 36 minus 4 is 32. That's my discriminant number. Now, because the discriminant was positive, I'm going to have two real solutions. Now, again, if that was a question that I would ask you, like on a test, for instance, it would be where I would ask you to find the discriminant, describe the nature of the solutions, which is what we just did, and then also solve it. But for the homework wise, it does not say solve it. So it's just me combining a couple things. Okay, so from there, again, the directions are going to say solve by factoring, solve by completing the square, solve the quadratic equations, and then find the discriminant. And that's about the extent of section 4. So I will talk to you later. Bye.